Four functions you should probably know if you write in Python are zip, map, reduce, and filter. I've made videos on these which explain the functions fully, as detailed as I could get it to, and hopefully you have watched them or watched another video and understand the theory of it and how it works. In this video, I'm going to be applying the functions with each other because that's where it really shines, and going through different examples, trying to get more realistic as we go along to show you how to use them in your own projects or just when you're coding. The first one, I've shown this in the reduce video. The simple answer is it grabs the iterable, it then squares it, so then you get 1, 4, 9, 16, 25. It then uses reduce to add them up together. So you get 1 plus 4 is 5, then 5 is now x. You then do x plus y, which is 5 plus 9, and then so on. That gives you 55. If you can't really be bothered to go to that video, the explanation is commented here. In this example, I'm going to be using zip, map, and filter. We have a list of students. Here is only 3 names, but you can do it for much longer. And we have the 2 different lists of assignments and exams, so the different scores they have gathered over the period of time. The goal is to see if they pass or not. For that, we use map, which is the innermost one. That's how we're supposed to read it. 50 and 70 are passed in as A and E, which are added together using this lambda expression. And then 45 and 55, 60 and 80. Zip then ties the names to the score. So the total score is tied to the name in a zip iterable. Filter is then used to see who got greater than or equal to 100. Anyone who's got 99 or less gets kicked out. Think of it like that. And then we make it into a list because at the moment it is now a filter iterable. Then we print it out to give Alice, Bob, and Charlie with 120, 100, and 140 respectively. I will get into dictionaries in a bit, which are more realistic for larger data sets. But first, I want to show you how to use all 4 of the functions in conjunction with each other. So in quite a similar fashion here, we have 3 lists: products, prices, and discounts. We have zip, which zips up or groups up products, prices, and discounts. So it groups up A to 100 and to 1.0.1. So in the zip iterable, the 0 index, the very first item, is A 100 0.1. The first index, or the second item, is B 200 0.2. Second index, which is C 150 0.15, or the third item, is grouped up as the third bit of the iterable. We then apply filter to see if any of them have 100 or less. If they have over 100, so 101 for example, they get passed on. The expression uses x index 1. That is the 0 index. That is the first index. Because 100 is not bigger than 100, it's exactly equal to, it gets discarded, so A is not included in it anymore. So in the filter iterable, A is not there, but B and C are. Then we get onto the map function. The map gets the first index, which is 200 in this case, or 150. The second index is 0.2 and 0.15. The reduce function then snowballs up them together. So it has a base value of x and it adds on y, and it does that until it reaches the end. That gives you this number, 287.5. Now, when you get to more advanced projects, you'll be using dictionaries quite often as they are powerful objects in Python. We have a dictionary of products: laptop, mouse, keyboard, monitor, and USB cable. We also have the prices and the quantity. Each of them are stored in a single dictionary. So that is a single dictionary. That is a key, the name. That is the value, laptop. Then there's a comma. That is a key. That is a value. That is a key. That is a value. Key value pairs are separated by colons, and each item in the dictionary is separated by a comma. Products is the iterable pass into it, which is a dictionary. So for every product, we are looking for the price. The price is a key. So we are searching in products for the key called price. Price is found over here, and we check if it's greater than 20. 1000 is greater than 20. 15 isn't. So we filter out the one with 15, which is this dictionary. So that product is filtered out. We then get to the reduce. This 0 starts off a base initial value. ACC, I named this because it stands for accumulator. So you can grasp your head around it a bit more. The initial value of the accumulator is 0. So the thing that we're iterating is 0. We have the product, which is each of these. Obviously, the ones that are greater than 20. So it'll just be this 1001, this 31, and this 251. We add the accumulating value, which at first is 0, to the product price. So for each product, we look at the price and we add it onto it. And we times it by the product quantity. What I mean by that is 1000 is being times by 1, because 1000 is the value of key and 1 is the value of quantity. We go to the next one, say 30, that is the value of price. So that value is the price of this key. Same thing, 1, which is the value of quantity, so you do 30 times 1. 250 times 2. That's what this line is doing. And it prints out the total cost, which is 1030. So in a data management sense, you might want to filter out the ones with low prices, because that doesn't really affect low margins. That's a realistic application. But it's just to show you how you can use the different functions along with stuff like dictionary. So we have some products, and we are going to update the prices of those products. That is what this bit is. You can tell it's a dictionary because of the curly brackets and the colon there. So this is a key and that is the value. We are updating whatever product we're on with this key and value. The value is whatever the price is, so 0.5, we times it by 1.1 and then we round it to 2 decimal places, because that's what that round bit does there. So that is the value we're applying to this key, which is the price. This asterisk product over here is essentially doing dictionary unpacking. We are modifying it, helps to modify it. I do plan to release a video for dictionaries and I'll go to more detail with it there. And this lambda bit, that's just saying for each product, so each value in this list or each dictionary. And then we map it up together to apply to all the dictionaries inside of this list. And we store it as a nice little list under the variable updated prices. The available products, we have a filter which filters out all the stock that is 0 or lower, and you can't really have negative ones, so it filters out anything that is empty and it applies the updated prices onto them. So the ones with no stock, the prices stay the same, and the ones with stock, the prices increase. And that gives this. Now, when you're using these types of functions, you might often have to use them with something called enumerate, which is particularly useful if you're doing a for loop and dealing with dictionaries. Enumerate basically allows you to iterate over 2 values at a time. That's like a quick watered down version or explanation. To go into more detail, We have some sales, which is stored in the list, and total revenue, which is stored as an integer. Of course, we have the products, which are same as before. So it looks a bit daunting at first, but breaking it down, zip combines the sales and this list together. So for every product in the list of products, so that is a dictionary, it combines that dictionary to that. So apples have 5 cells, bananas have 3 cells. That's what zip does, and it stores it into a zip iterable. Enumerate keeps track of what product we are on. So at index 0, which is this, enumerate would then be 0, but then when we go to the next product, enumerate would make this index into 1, and it will also update this as well. So at the same time as index goes from 0 to 1, so does the product sale zip. So the index is 0 here, and then when this is done, enumerate then makes it so it goes to the next one. Product stock, so for every product, the stock key, it grabs that value, which is 50, and it then takes whatever that value is by sale. So in this case, the sale is 5, which means that we now have 45 apples in stock. Revenue then times whatever the sale is by the product price. So it grabs the key value price and it finds the value of it. So it grabs the key, which is called price, and it finds the value 0.5, and it times it by the sale. So it does 0.5 times 5. But it times the sale together, and that's the revenue. And the total revenue will just be whatever the revenue is summed up. So this starts at 0, and then you increment through apple, and that gives you whatever value it is. And then when you go to banana, it still stores that same value. So then when you calculate the revenue of banana, you can just add it on. So this print statement over here essentially does this bit around here. We get apple, we have sold 5, and the new stock, so the stock we have remaining is 45, and the revenue is 2.5 kip. I want to say, I forgot the name of that currency. It's a K with a tiny dash. So that just corresponds with that. I use an F statement for simplicity's sakes. And then we just have the updated product data and the total revenues showed here. So the total revenue is 32.9. So technically still a profit, but if we just sold apples, we'd be broke. You probably have noticed this text file I have on the top here. That's because often when you're dealing with Python, you're going to be using text files, CSV files, or that type of thing. You're extracting data from an external database or internal database. We're starting off by having the text file here, just neatly laid out. And we're opening it with this line. With this line. We're not opening text files, you should do it like this as it's more safe. File.close here is not necessary because we're opening it as file. I still put it in for good practice. We are trying to find all the errors within the system logs, presumably so we can fix them, but we need to know what they are first. So we use the lambda function to iterate through every line in the file. So this is the first line, and we try and see if there's an error. There's no error here, but there's an error on the second line. So when we do get to the second line, it then doesn't filter out, it keeps it. It then line.strip removes all the white space at the end of it, and then it prints it out. So now we know there's an error. And for the final point, we are dealing with different functions. So we have a list of sale quantities and revenue per product, and we want to see if they meet the threshold and that kind of stuff. We have the quantity sold and we have the revenue, each stored as separate lists. This function finds the average revenue per item using the amount that are sold and the revenue collected from each one of them. So if the sold is bigger than 0, so if whatever the thing we sold is greater than 0, which means we have sold something, then you do the revenue divided by the amount that was sold. If not, it's 0 because it means we haven't sold anything, so no money was gained. Average revenues does average revenue per item, so that function, and applies it to quantity sold and revenue. Remember, maps applies the same function to everything inside of the list or iterable. So it applies that function to quantity sold and revenue, where quantity sold as an argument for sold and revenue as an argument for revenue. It then stores it as a list using this variable. Usually you would want to store the variable after you declared all the functions, but this is just for an example. The next function is if it meets a certain threshold. So we grab it wherever the threshold is, and we grab the average revenue, and we just see if it's bigger than or equal to that threshold. We'd use the partial function here to store a certain value. In this case, it's 5. So that 5 is stored as a value, but the filter function only accepts 2. Average revenues, which is been declared earlier. So that's the iterable we want to go over, and this is the function we want to apply to this iterable. Because this inverse variable is a function because partial is using 5 as a placeholder, and this is the function we actually want. So after it calls meets threshold, we then get the average revenue per item, which is over here, and then the filtered average revenues. If it's bigger than or equal to $5 per item, and we get it here. So hopefully my explanation was well done. If you think I gloss over something too much, please mention it. I'm always trying to improve my descriptions and explanations for stuff. Other than that, check the rest of my Python playlist for different aspects of Python. And I have a Code Wars playlist to walk through some examples that other people made over the internet. And I'll see you on whatever video you choose. Peace.